Geometric Transformations. This is a digital lesson, and this one is St. Patrick's Day themed. So it covers the transformations of reflection, translation, dilation, and rotation around the origin. It's a lot of fun for the students. They can use the fill color feature of Google Slides in order to show their transformations. So the lesson starts with explaining what transformation means and what it means in mathematics. And then they're given the definition of these 4 transformations. They can refer back to slide 3 if they need to. And then they start on slide 4. So they're given a shape here, and they need to reflect this figure across the y-axis. So it needs to be equal distance from the y-axis and a mirror image. So to do that, they click and hold in one of the squares that they want to color in. Click and hold and scroll across until they have a rectangle shape. And then they come up here to the fill color feature, and they can choose any color they like. And then they just continue filling in until they have that mirror image. Next slide, they've got a T shape, and this one they're also going to reflect across the y-axis. And again, equal distance from the y-axis and a mirror image. When they get to slide 6, it's the same shape. This time they're going to reflect across the x-axis. So it's going to be straight up. It's going to look something like this. And again, they can choose any color they like. The next slide has them reflecting across the line x equals 1. So again, it's going to be a mirror image, but this time it's going to be equal distance from the line. And then they're going to reflect across the line y equals -1, so it'll be down here at the bottom. Then they're shown what to do when they have to reflect across a line and their figure's already partially across that line. So I have 2 points here, and this is going to act like a hinge, as if they just flip this figure straight up, and they can see what that's going to look like. So they're going to attempt that on the next slide with a different figure. Then we move on to translation. So translation is just moving up, down, left, or right without changing the orientation of the figure. So this one, they're just going to move this figure 6 units to the right. So 1, 2, 3, 4, 5, 6. Again, shade in what they need to shade in, and then choose any color they like. The next slide, they're going to translate this figure by moving 4 units to the left and then 2 units down. And then they've got one more where they're going to move in 2 different directions. And then finally, this kind of different shape here, so it's a little bit more of a challenge. Then we move on to rotation. With rotation, this is rotation around the origin. So they're going to rotate this figure 90 degrees, and we're going to go counterclockwise. So that would place the new figure in quadrant 3. And we're rotating that whole figure all the way, but we're only going to show 90 degrees. So they're going to take each one of these points. They're going to take the coordinates. So this is -1, 2, and we're going to use this formula to get the new point. So -1, 2 will now be -2, -1. And they're going to click and hold on one of these movable points here, -2, -1. Now the next point is -1, 4. If we use the formula, it's now -4, -1. And then -3, 2 will be -2, -3. And then they've got these movable pieces that they can use to finish their triangle shape. So here is a rotation, 90 degrees counterclockwise. The next figure, they're going to rotate this one clockwise 90 degrees, so that would also place it in quadrant 3, and they're going to use this formula for their new points. Now here we're going to rotate 180 degrees, so that would place this figure in quadrant 4, the opposite quadrant. And they're going to use this formula. When they get down to slide 18, they're going to show the full rotation around the origin. So they've got all of the different formulas that they're going to use for the three rotations. So they've got purple points here, yellow for this quadrant, black for this quadrant. And when they're finished, they'll show that full rotation. Then we move on to dilation. So dilation is changing the size of a figure without changing its shape. And we're going to scale up or scale down by a scale factor. So if we dilate this by a scale factor of 2, that means the new figure is going to be 2 times larger. And since we're using the coordinate plane, we're going to take the coordinates of each point and multiply by the scale factor. So instead of 1, 1, the new point will be at 2, 2. And for negative 1, 1, it'll be negative 2, 2, and so on. And then we'll create a figure that's 2 times larger. And then they can use these side pieces to fill in for the entire square. The next one, we're going to scale up by a scale factor of 3. So they're going to take the coordinates of each point, multiply by 3. And then we have a scale factor on slide 21 of 1/2, which means if it's a scale factor that's a fraction less than 1, that means our new figure is going to be smaller. So they're going to take the coordinates of each of these corner points and multiply by 1/2 or divide by 2. On slide 22, we're going to use 2 different transformations of the same figure. They're going to first translate this figure 5 units to the left and then reflect it over the x-axis. The final slide has drag and drop vocabulary, so they're just going to take each one of these, click and hold on the edge, and they're going to move it into the correct place in the sentence frames. So this is a digital lesson, Geometric Transformations, the St. Patrick's Day version.